So let's just say that you have invented a test that will detect whether whether a person has some specific type of cancer. So um, what we're wanting to know, what we if you have such a test and somebody comes in and takes that test and they get a positive result on that test, what they really want to know is what's the probability that they have cancer given that they got a positive result on that test, right? So let's say you had, Sally walks into the hospital, takes this new test, and she really wants to know, okay, I got this positive result. What does this mean for me? So we want to find out the probability of cancer given that she got a positive result on the test. That's called a conditional probability, right? We have some other probabilities up here you can see. And this is sort of a base rate probability in the context that we're going to talk about it in just a little while. We call that a conditional probability. Or excuse me, we call it a prior probability. That's a prior probability. So it's just base rate probability of having cancer. So if we want to know the probability that Sally has cancer given that she got a positive result on this cancer test, we need to know these other three things here. We need to know the base rate probability of having cancer out there in the population. And I just made these numbers up, by the way, over here in column B. So we can just pretend that that's 5%. The probability of getting a positive result given that the person has cancer. So I'm going to say that's 95%. So sounds pretty accurate, right? The probability of getting a positive result given not having cancer. So right, this is like a false positive. This would be a false positive. This here would be a true positive. Whoops. And this would be our base rate or our prior probability. If we know these three things here, we can actually determine this thing here. And how do we do that? That's Bayes' theorem, and it's really important for not just naive Bayes, but a lot of different kinds of classification problems, because there's sort of four different outcomes when you're classifying things. You can have a true positive or a false positive. You can also have a true negative and a false negative. And you need to know what those things are in order to, say, validate a model that classifies things. And in naive Bayes, we're working with conditional probability, so I wanted you to have that vocabulary. But Bayes' theorem kind of introduces you to this way of thinking that can sometimes be pretty counterintuitive. So you see the probability of A given B, we can determine that. This whole thing here is just a single number, right, between 0 and 1. And these other terms here are just single numbers between 0 and 1. We can compute this if we know these numbers here. So pretty simple. I'm not going to work through the equation. I'm going to show it to you in a visual way that will hopefully sort of shed some light on this counterintuitive aspect of how this all works. So I'll do that in the next video.